All right. We are starting today on 9.5. We are not going to finish 9.4 right now. We'll finish that whatever I want to on Monday. You do have 9.4 homework due on Monday. It's the one that says 9.4, like part one or number one. It does, it looks like stuff you can do. I do not want you to do the one that has the LIMs, the limits on it. So don't worry about that. We'll worry about that another day. But your other 9.4 homework is due on Monday. Okay, we're going to get through as much of these 9.5 notes as I can. We may be skipping around. We may not do all examples, but that's going to have to be okay. So first thing you might notice that this is not a normal notation for us. We've got this kind of funny symbol. We've got numbers and letters above and below. This is what we call summation notation. Summation notation. That makes you think of 101 Dalmatians. That might be a deep cut. If you know, you know. Let me know later if that makes you think of 101 Dalmatians. But summation notation is what we call this. Another name for it is sigma notation. For those of you with any kind of familiarity with the Greek system, sigma is a letter you maybe have seen on Greek row, whether it's for a sorority or fraternity. That's this E-looking letter right there. It's the sigma. And sigma is that S because it means this is a sum. So sum, we are adding these pieces together. What this is saying is that n equals 1 is where you're going to start. You're going to start by plugging 1 in for your n that's in your equation. And you're going to continue doing that, summing those terms until you get to the number on top, which is the end. Okay, so we're going to do it one piece at a time. So we'll do 2 times 1 plus 3. That's one term. You plug 1 in. Now we're going to plug 2 in. So we're going to add that to 2 times 2 plus 3. That's my second term. Add that to 2 times 3 plus 3. And then add that to 2 times 4 plus 3. So you're just plugging in 1 through whatever the top number is into your equation, into your expression. And then you're going to solve what those terms are and add them together. 2 times 1 is 2, 2 plus 3 is 5. 2 times 2 is 4, 4 plus 3 is 7. 2 times 3 is 6. 6 plus 3 is 9. 2 times 4 is 11. 11 plus, or sorry, 8. 8 plus 3 is 11. You get the gist. And then we're going to add them together. You can do that in your calculator. It's just going to be 32. Or you can do it by hand. I don't really care. All right, let's do another one. This time we're going to start with not 1, but we're going to start with 2. And we're going to end at 6. So we're going to do 2 minus 1. That's the first term. And then we're going to say plus 3 minus 1. And we're going to go all the way until we get to 6 minus 1. Every time we're going to add the next term to the terms in front of it. So 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, 6 minus 1 is 5. Then we're going to add all of those numbers up together, and that is my final answer for this problem. So summation notation is just how we write things. We're writing in a way that we're summing stuff. So we're summing all of these pieces up. Go ahead and try letter C on your own. It's the same thing. Just plug 1 in, 2 in, 3 in, 4 in, and then you're done. You add them all up. So I'm going to be quiet, but I'm going to write my answer over here. All right, once you do that, you should get 30, which is the same thing that I got. I want to jump in and do something on the calculator really quick to just kind of show you this notation. And we're actually going to go back to the very first one because I think that that's just a good one to think about. We're going to try and plug this into the calculator because when you turn the page, you'll notice that we're going to want to plug it in the calculator. We're not going to want to do that one by hand. When you pull up your calculator, I want to get this sigma notation. I was already practicing before this, so don't worry, we can do it. If you go to math And then if you just scroll down, don't go over any, just scroll down to letter 0, it says summation, and then it looks like a sigma. Now this is in kind of newer calculator. If you have an older one, I'm going to have to help you on Monday because I'm not really sure what all the like buttons and ways to do it are. But when you press that, it gives you the opportunity to plug things into all the pieces. The only thing is we don't really type N on our calculator. So instead of N, I'm just going to type X, which is that variable button that we press often when we're graphing. I'm going to say X, I'm going to say 1, and then it feeds me to the number up top. So I'm going to write 4 because that's where we're ending. And then I'm going to put my expression in there, 2x plus 3. Press enter, and it gives us 32, which is exactly what we got when we did it by hand. It wasn't hard for us to do these by hand because we were only going to 4 or 6. But if you flip your paper over, I think this is the only one we're going to do on this side. But if you flip your paper over, I don't want to sit and do this 100 times. So I just wanted to show you how to do it in the calculator. I showed us an easy one so we could check our work, but now we're going to do one that we don't know what it is by hand to see what it is in the calculator. So again, hit math, go down to 0, which is summation with the sigma. We're going to say X and 1. And then the top is going to be 100. And then we're going to say 2x minus 3. And then we're going to press enter. That gives us this big number, this 900 or 9,800. That's okay. If we were to do this 100 times out, if I was to plug in 1 and then 2 and then 3 and then 4, blah, 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 all the way to 100, this is what I would get when I added up all the pieces. I really think that's most of the calculator stuff. Any little calculations I'm just going to do by myself on my own calculator. So I'm not going to pull that back up again. If it is helpful to you, feel free to write all of your little equations here, but I'm going to write them further down once we learn a couple new ones. So I'm going to kind of skip that for now. And I'm not worried about these 2 problems currently. I'm going to jump to number 2, where basically we're going backwards from what we just did. On number 1, I gave you the problems in this notation, and you gave me, and then we gave like the list of numbers and then added them up. Now we're going to go backwards where I have a list of numbers and I'm going to write it in summation notation. Okay, that means that I need to have my sigma ready to go. I need to have N equals, and then where we're starting at the bottom, where we're ending on top. And then in the like parentheses is kind of how we get to each one. When it's applicable, I want to try and use our formulas for our arithmetic sequence and our geometric sequence. So if you remember, if you go back in your notes to 9.4, we've got arithmetic and geometric sequences, and we're going to kind of build on those today. So my first question here is, which one is this? Is this arithmetic, where you're adding or subtracting to get to the next term, or geometric? This one's arithmetic because we're adding 6, adding 6, adding 6. And then it skips a lot of numbers and we end at 53. Okay, we end at 53. So what I'm going to do is I'm going to start by figuring out what's my expression here. Okay, I will tell you that most of the time, if not all the time, my number at the bottom is always 1. So you can just go ahead and fill that in. My arithmetic sequence was a sub n equals a sub 1 plus n minus 1 times d. I have a sub 1 and I have d. We can write a generic formula, our explicit formula for this from that. So a sub n equals -7 plus n minus 1 times d, which is 6. All right, I'm going to distribute that 6 to simplify it. 7 plus 6n minus 6, or sorry, -7 plus 6n minus 6. So 6n minus 13 is my expression. So that's what I do to get to the next term every time. I'm going to write that 6n minus 13 in here. That being said, what I haven't figured out yet is what number goes on top. Now, could you just keep adding 6 as so many times and see which number gets us to 53? Absolutely. What you could also do is just set this expression equal to 53 and then solve for n. So I can say 53 equals 6n minus 13, and I can figure out what n is. Add 13 to both sides. I get 66 equals 6n. And then when I divide by 6, n equals 11. So that's the 11th term right there. So I'm going to go put that in the top of my summation notation. So you're not done with your summation notation until you have a number where you start, a number where you end, and then the expression in which you use to find all of these things. Okay. If you look at the next one, I don't think it's really obvious to use an arithmetic or a geometric sequence. So I kind of looked and I sat and I thought about like how these numbers relate to each other. Take a second, see if you can think about how they're related. Pause if you really want to think it out. If you've thought it out or you have a guess or you're like, no, just tell me. These are all perfect cubes. So this is the same thing as 1 to the third, 8's the same thing as 2 to the third, 3 is the same thing as 27 to the third, and 64 is the same thing as 4 to the third. So when I thought about this in summation notation, I've got my sigma, and I'm going to start with n equals 1. And they're all like increasing numbers raised to the third power. So it's going to be n to the third power. That's how you get each individual term. And this one says ... which means that it goes on and on forever. And so we put an infinity on top to represent that it goes on and on and on forever. Okay. Now, I gave you an arithmetic one. I gave us one that we just kind of thought up in our brain. Now I'm going to give you a geometric one. So this one is a geometric one. One way you know that, and we kind of talked about this in class, is we're alternating between positives and negatives and positives and negatives. You cannot add and subtract and keep going back and forth between positive, negative. You can only do that if you're multiplying. And I'm going to do that by multiplying by -3. So that means if I'm thinking about this as my geometric sequence, a sub n equals a sub 1 times r raised to the n minus 1. I know my a1, that's 5. I know my r is -3. And then I don't know what my n is. So my general form is 5 times -3 raised to the n minus 1. That's basically my sigma notation. Got to put a sigma in front. Got to put all of our little numbers in. We're starting at 1, so we plug 1 in for n, and if you plug 1 in for n, you'll get 5. And this one has another ... which means it also goes on and on forever. Infinity. Okay. I think that's really all the sigma notation we're going to do for today. Now, for the last little bit of this video, lesson, whatever, we're going to skip letter D. I'm not really worried about that right now. Now I want to get into series. So we did sequences. Series is now taking those lists of numbers and finding the sum of them. So I've got equations for you there. So I'm actually going to take this space over here and write some equations, maybe like this area right here. So first thing I'm going to do is remind myself my sequence formulas. So my arithmetic sequence, and we just used this a minute ago, so it should be fresh in your brain. A sub n equals a sub 1 plus n minus 1 times d. And then my geometric sequence, again, we just use is a sub n equals a sub 1 times r raised to my n minus 1. Those should not be new information. That should not be new to you. What is new to you, and I encourage you to have written that down, even if it's not new to you. I still want you to know it. And the new stuff to you is series information. I've got 3 little series formulas. I've got arithmetic series. I've got geometric series. And I've got something called infinite series, which kind of, we alluded to that already. The sigma notations with those infinities on top, that's an infinite series, an infinite list. Arithmetic series is when you have a list of numbers that add and subtract just like arithmetic sequences, but you're doing the sum of all of those. So the formula we're going to use for that is going to be S sub n equals n over 2 times a1 plus a sub n. S sub n means sum of this list of numbers. Sum of n terms. N is how many number of terms we have. A1 is my first term, as we should know, and then AN is my nth term. Let's actually go use that right now. Let's go do this. Pause if you need to write it down. All right, this is my list of numbers. See how it ends because there's like nothing after this. There's no missing pieces. I have all of them. Technically, could I add this in the calculator? Absolutely. However, we have this formula for when I can't add it or when there's too many numbers. Okay, so first thing I'm going to do is figure out how do I get from one to the next. I'm going to add 4. So you know it's arithmetic because I told you we were doing it, but it's an arithmetic. My D, my common difference is 4. Okay, my formula that I just taught you was that S sub n equals n over 2 times A1 plus AN. So we got to plug in our pieces. S sub, how many terms do I have? 1, 2, 3, 4, 5, 6. I've got 6 terms. So A sub 6 equals n again, 6 over 2 times A1, that's my first term, plus AN, which is my last, it's my 6th term, or my nth term, whatever makes you happy, 13. Now we just take that and simplify. S sub 6 equals 3, negative 7 plus 13 is 6, and then 3 times 6 is going to be 18. So the sum of those 6 terms is going to be 18. Let's do letter B while we're at it, because if you're looking ahead, it also is an arithmetic sequence. I've got negative 17, negative 110, negative 103, and then I've lost a lot of room, a lot of numbers, and then I have 33. Okay. I have a lot of information. I know what my common difference is, minus 7. I know my A1 is 117, and I know my AN is 33. However, when you go to plug it into your formula, S sub n equals n over 2 times 117 plus 33. I can't do very much until I get what n is. So we need to figure out what n is. What we can do is we can use the formula kind of like we did up here. Remember how I said like, oh, we found the expression and then we set it equal to the number term that we didn't know what it was. So we had a number to put on top. We're going to do the same thing down low. We don't really need to do it in 2 steps. I think we can just combine it in 1. So let's see what that looks like. I'm going to use that formula, A sub n equals A sub 1 plus n minus 1 times D. And I'm going to plug in what I know. I know A sub n is 33. I know A sub 1 is 117. I do not know n, and I do know D is negative 7. Anybody questions on that? I mean, I ask and nobody's here to ask a question, but make sure that makes sense. A sub n, the last term, is 33. The first term is 117, and my D is negative 7. Okay, now we're going to go solve for n. You guys can do algebra. Multiply by negative 7, so I get 33 equals 117 minus 7n plus 7. I'm going to add those two together before I minus them from both sides. So 117 plus 7 is 124. Hope that's right. Yeah, that would have been embarrassing. Minus that from 33, which is negative 91 equals negative 7. And then I divide that by negative 7, and I get n equals 13. I need this information, not because it goes on top of my sigma notation. It's because I can't solve my series if I don't have n equals 13. So this is saying first term, second term, third term, we're missing 4, 5, 6, 7, 8, 9, 10, 11, 12 term. We're missing 9 terms in the middle. And then this is my 13th term. We just skipped a bunch. Remember when you were little, you'd be like 1, 2, skip a few, 99, 100. That's what this does. So we did 1, we did 2, we did 3. Now we skipped a few and now we're at 13. All that means is I'm going to go plug 13 in for these ends. I don't like to make it a decimal until I absolutely have to. So I'm going to keep it like that. And when I do 117 plus 33, that does give me an even number. So I can divide that by 2. So that's 75. And then 75 times 13 is 975. So the sum of those 13 terms is 975. All right. Before we carry on, we've got to learn about geometric series and infinite series. So geometric series looks like this. S sub n equals a sub 1, 1 minus r to the n over 1 minus r. My r is my common difference. My n is my number of terms. My a sub 1 is my first term. This one's a little easier because I don't need my a sub n term. But I do need my n, so I might have to do some searching and finding for that. All right, pause that, take a picture, write it down. Okay, I'm going to move on. I'm only going to do one of these geometric ones right now. Okay, right here. This one we know is geometric because we're multiplying by 3 in order to get to the next term. Okay, so that's my r. We've got geometric. We know r equals 3, and then we know our a sub n equals this number. Unfortunately, we also have a sub 1. Unfortunately, if this was arithmetic, we'd be ready to just go and plug it in. But we don't know what term we have, and we need to figure that out. Just like we did last time, we're going to use our original geometric sequence form. an equals a1 times r raised to the n minus 1 in order to find our n. Now, this is going to be the hardest thing we do today, which is fine, but it's going to make you remember back to December, which I'm sure a lot of us don't. My a sub n is that 98,415. My a sub 1 is 5, and then my r is 3. Okay, the first step is super simple. Just divide by 5. I'm actually not going to write that. It's that simple. And when you divide by 5 on both sides, I get 19,683 equals 3 raised to the n minus 1. It may help you to flip it around. And then if you remember back to December, we were doing logs and exponentials. So I could log roll this and put it in logarithmic form. Log base 3 of 19,683 equals n minus 1. We can go ahead and put that straight into the calculator. You also at this point could like guess and check and be like 3 to what power gives you that? And you can plug it back and forth into the calculator. But I will tell you, I'm not wasting time guessing and checking. So I'm going to do this. I guess I lied. I guess I will pull this calculator up really quick. Math. Log base is a, log base 3 of 19,683, and that is 9. So 9 equals n minus 1, add 1 to both sides, n equals 10. Now we need that by calculator. If any of you feel lost, it's just because you don't remember log. If you want to go back and guess and check, I promise if you tried not 3 to the 9th power, you're going to get this number. So whatever floats your boat. That being said, n is 9. So now I'm ready to use my geometric series formula. S sub n equals a sub 1 times 1 minus r to the nth all over 1 minus r. So I'm going to go plug in 1 and r and n. I'll scoot my screen over in case you couldn't see that. S sub 10 equals a sub 1, which is 5, 1 minus r, which is 3, raised to the 10th, all over 1 minus 3. You can put that all in the calculator. Make sure you just put the bottom in parentheses and make sure the only thing being raised to the exponent is the 3. Yeah, I was going to do this without the calculator, but I'm nervous that you guys need it. So I'm going to say 5 parentheses 1 minus 3 raised to the 10th. And then I close that parentheses divided by, and if it makes you happy, you can do 1 minus 3 in your head, or in case you don't want to, you can also do it in the calculator. And my sum, just like how arithmetic sequence, that number gets really big, obviously the sum of those big numbers is also going to be very big. So 147,620 is my number here. Okay. Get rid of the calculator. All right, next thing we need to do from here is we've got 2 more kind of concepts I want to talk about. One says find the sum of the first n terms. And then the next, we're gonna do those A and B, and then we're gonna do at least 1 or 2 infinite series, which is the blank that I've left over here, but don't worry, I remember it's coming back to it. Okay, so between these 2, one of them is arithmetic, one of them is geometric. Let's look and see. The first one, it looks like I add 3, and then I can add, okay, yep, that works. Add 3, that seems like the best way. So this is arithmetic, and we know that series formula looks like this. And if you don't, go back to your notes. S sub n equals n over 2 times a1 plus a sub n. Things are looking good. I already have my n, which is 90. I have my n, which is still 90. I've got my a1, which is -2. Wait a second. I don't have a sub n. How do I find it? Go back to your sequence formula. It all goes together. Everything's hand in hand. A sub n equals a sub 1 plus n minus 1 times d. So I can use 90 as my n. We know what my d is. It's 3. And I know my a sub 1 is -2. And I want to find my 90th term because that number needs to go right there. -2 plus 89 times 3. 89 times 3 is 267, and then plus -2 is going to be 265. So 265 goes right there. Okay. Once you've done that, now we just plug and chug. 90 divided by 2 is 45. -2 plus 265 is 263. 263 times 45 is going to be 11,835. 11,835. The only problem we had to do before we could just plug and chug was plug and chug into an old equation and use that in our new one. Okay. Let's go look at B. This one, it says we've got 0.2 or 0.1, 0.2, 0.4. I know decimals kind of freak us out. Basically, what we're doing is we're multiplying by 2 to get to the next term, which makes it geometric. And it makes our R2. Now let's see what our geometric series is, see if we need to do any work. S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. Ooh. We have a sub 1. We have r. Oh, and we have n. Yes. We don't have to do any extra work. We just have to plug those 3 things in and we have to go from there. So S sub n, S sub 12 is going to equal a sub 1, which is 0.1, times 1 minus r, which is 2 raised to the 12th, all over 1 minus 2. I will remind you on this, it's probably easier to just do 1 minus 2 in your head and remember that that's just -1. So you can just do whatever the numerator is in your calculator and just multiply that by -1 or divide it by -1. For sake of your time and mine, we're just gonna know that the answer is 409.5. Okay. I'm gonna skip C. If I want to come back to that later, I will. The last couple minutes I want to spend on something called this infinite series. So I'm going to go back in my notes so all my equations are together. Infinite series is when like the series goes on and on forever, when there's a dot, dot, dot at the end, but a lot of them like head to just one certain number. And so an infinite series equation would look like this. S of n equals A1 over 1 minus R. It doesn't matter how many terms there are because there's infinite. You can't plug that into the calculator. So all we care about is essentially the geometric series, just without that 1 minus R to the n. Okay. If you look at number 5, that next set of directions says infinite series. That's my cue to use this new equation. Okay, so S of n equals A sub 1 over 1 minus R. I know what A sub 1 is, just my first term. My next term, okay, to go from 3 to 3/2 and then to 3/4, I'm multiplying by 1/2. Oh, that's really messy. Let me try again. Times 1/2. Okay, that means when I plug that in, S of n equals 3 over 1 minus 1/2, which is 3 over 1/2, which is the same thing as 3 times 2 over 1, or 6. So that means it doesn't really matter what all these next numbers are. They're eventually going to get closer and closer and they're never going to reach 6, but they're going to get close, almost be 6. The sum of the infinite series, it will never quite reach 6, but it will never go past 6 because we're getting down to these tiny, tiny fractions, decimals that only get smaller and won't push us over 6. There's just 2 more. Let's do B and C really quick, and then we'll call it a day. All right, so B, what do we need to do to go from the first term to the second term? Times negative 1/2 this time. Remember, when you switch from positive to positive, you got to deal with a negative when we're multiplying. All right, so S of n equals A sub 1, which is 4, over 1 minus my R. So minus a negative 1/2, which will make it plus. Well, that gives me 4 over 3/2. I know we panic with fractions, but you can do this. 4 times 2 over 3. Doesn't cancel, but that's okay. 4 times 2 is 8. 8 over 3 is my final answer. I actually think these are the easiest. All right, last one. 6, 4, 8/3, 16 over 9. This one looks confusing. Sometimes I actually like to go to the fractions to decide what happens. So in the bottom, we multiplied by 3 to go from 3 to 9. And on top, we multiplied by 2 to go from 8 to 16. So my difference, my ratio is 2/3. S of n equals A sub 1, which is 6, over 1 minus 2/3. Don't cheap out on me. 1 minus 2/3 is 1/3. You guys know that. 6 over 1/3. And the reason I'm being like this about it is because look how easy it's going to get. When you multiply by the reciprocal, it's 6 times 3, which is 18. Work smarter, not harder. Okay. All right. We've got one more day of lessons on this stuff, but I just wanted to get the majority of 9.5 done. Remember, your 9.4 homework is due on Monday. You are responsible for notes. So when I see you on Monday or Tuesday or whenever your class meets, I expect this to have been taken and I expect your homework ready to go. If you have any questions, feel free to email me or come to office hours on Monday. Have a good weekend, guys. I will see you.